Hey there, this next question, number 14 on the Unit 2 example question set, it says in the instructions to solve using either substitution or elimination. So you may have noticed that up until this point, I have pretty much just used matrices. And if I'm being honest, that's because matrices are fast, easy, reliable, and they don't require a whole lot of work to be written down. Unfortunately, on 14 and 15, we have to use either substitution or elimination. So I'm looking at the equations, and what I see is I've got three of them. There's two variables in the first one, x and y, three variables in the second one, x, y, and z, and then two variables in the third one, y and z. And what I'm noticing is that this first equation in this system, the variables are on opposite sides of the equal sign. Usually if I'm going to use elimination, I want everything, all the variables on the same side of the equal sign, and I don't have that here. Also, I noticed that if I were to divide by 2, I could figure out what x was equal to in terms of y. So I thought, let's do that. So 2x equals 4y. I'm going to divide both sides by 2. So x equals 2y. Now, that's actually pretty useful because then I can take that and plug that into nowhere. That's fun. I can, wow, okay, I'm not sure what I'm going to do with that yet. I did notice one other thing, and that is that I can combine these. Man, I thought I was using substitution, and that's not to say that I can't, because I could. In fact, what I'm thinking is I'm going to put 2y in here. So follow along. So 3x plus 2y minus 4z will equal 52. And if I put 2y in for that x, I get 3 times 2y plus 2y minus 4z equals 52. And 3 times 2y is 6y, so I have 6y plus 2y minus 4z equals 52. 6y's plus 2y's is 8y, so 8y minus 4z equals 52. Wow, this is getting long. And what I noticed is this has a negative 4z, and this equation has a positive 4z. So I'm going to combine them. I'm going to put 3y plus 4z equals 14, and I'm going to add down 8y's plus 3y's is 11y's. Negative 4z's plus positive 4z's is 0, which is what we're looking for, actually, is a 0. 52 plus 14. 2 plus 4 is 6. 5 plus 1 is 6. So I have 11 times y equals 66. And I will divide both sides by 11, which means y equals 6. I am starting to get close to home. So then I can take that and plug it in over here. So x will be 2 times 6, which is 12. And then lastly, I can plug 12 in for x here. Actually, you know what? I'm not. I'm going to save myself some trouble and go there. I'm going to plug 6 in for y here and get z. I wish I had a little more room. Let's do that over here, I guess. So we got 3 times 6 plus 4z equals 14. Let's see. 3 times 6 is 18. So 18 plus 4 times z equals 14. I will subtract 18 from both sides. 18 minus 18 is 0. 0 plus 4z is 4z. 14 minus 18 is negative 4. So I have 4 times z equals negative 4. And if I divide both sides by 4, I get z equals negative 1, which is awesome. So my answer is x, y, z equals x was 12, y was 6, and z is negative 1. And there you go.